Hello everyone. So today we will discuss about how can we implement a circuit breaker with Resilience4j. So in this session we will talk about like this particular thing like using like circuit breaker implementation of the circuit breaker using Resilience4j. So before going into the detail of it, let's understand what is Resilience4j. So if we are talking about the Resilience4j, so it's a very lightweight process actually, and it's a easy to use fault tolerance library. This is a Java library basically, and it provides several resilience pattern for building fault tolerance applications. It is designed to help fault tolerant and scalable applications with minimal effort. This is basically designed for easy to use and integrate into the applications. It also provides flexible configuration system that allows to customize the behavior of each resilience pattern to suit their specific needs. For example, if we want to like write some applications, maybe it's communicating over the through network with another applications. For example, if we take any like any kind of e-commerce applications, which basically from here what customer doing, customer place an order. So for that maybe we are having a two microservices. One is the order microservice and another one is the stock microservice. So the responsibility wise, order ms is only like place the order. Maybe we need to like put some request, and then this particular order, actually order ms, from the order ms internally it is calling the stock ms just to check or maybe for deduct the quantity from the stock management. So if we are going to do this implement, so maybe like internally order ms internally calling this like stock microservice. So there is a some kind of the network call, remote connectivity is there, right? So due to this, whenever it's connect to the means is there any remote connectivity is there, so obviously there like certain things that we need to like concern, like about the connectivity. Maybe the stock microservice is down, or maybe there is a chance of timeout, or maybe broken the connections, and also maybe if the stock image is not available on the same time. So this kind of situations may appear. So Resilience4j is a library that helps us to build these resilient and fault tolerant applications. It provides a framework for writing code to prevent and handle such issues. So the circuit breaker actually is one of the main feature provided by Resilience4j that I am going to demonstrate in this session. Now let's talk about the different modules of Resilience4j. So Resilience4j, as we can see over here, this having this six modules actually. One is the retry, rate limiter, time limiter, circuit breaker, bulkhead, and the cache. Each module having different types of functionalities. Like retry is basically used for automatically retry failed remote operations. Whereas rate limiter is define how many times we call a remote operation in a certain period. Similar kind of thing, time limiter set the time limit when calling remote operations. And the circuit breaker, it's basically fail fast or perform default actions when a remote operation is continuously failing. Bulkhead basically used, it's basically like limit the number of concurrent remote operations. Using this we can means we can provide the limitations kind of thing. And caching basically it's a store results of costly remote operations. So these are the like basic functionalities of this one. As I said, these are also like very means this will also take some time for explaining those things. So all this point not possible to cover in this single video. So for that maybe I will try to cover those things in a next video. But in this video tutorial I will try to cover this circuit breaker module. Next, like circuit breaker. So like this circuit breaker actually uh, for enabling this one into any project like Spring Boot project, we need to add one dependency like a resilience circuit breaker dependency into your projects. Once this particular dependency is added, is done, then we can create a circuit breaker instance and we can use it. Circuit breaker basically used to prevent calls to a remote service if we know that the service call is going to fail or time out. This is necessary because we don't need to means we don't want to unnecessary call, right? Because it's a waste of resources. Suppose if we know that the endpoint or the remote service is already down, so if we are is regardless of this thing, if we are going to call this one, then it's a waste of the resources, right? Means we need to call this one, then wait for the responses. So instead of that, we don't need to call this one. So this is this is the thing, right? So now the thing is that how do we know that a call is likely to fail? So we need to keeping a track of the result of the previous request made from to the remote service, right? For example, if 3 out of 5 calls result in a failure or a timeout, then the next call will likely also fail. Okay. So a circuit breaker actually keeps a track of the responses by wrapping the call to the remote service. When so now here is the thing. So this circuit breaker actually internally use some status. Let's check out this diagram. So this having the open, half open, closed. So for example, initially it's a closed state, mean now some request is failed with the threshold limits, because for this obviously we need to provide some threshold, like when it will be we will say as it's a field. So maybe you need to the threshold will be a 50% of the request, or maybe 30% or 70%. Based on that it will decide, and if it is failed based on the threshold limit, then it will from the closed it will go to the open. So then like from and again like if there is a certain like configuration or maybe timeout we need to set, based on the timeout again from the open to it will be a hub open. So in this scenario in the hub open it will allow to process certain like some of the request and check if still it is available or not. If it is available, then after certain threshold period it will again closed. If from here in this section half open, if we still again getting the fail based on the certain threshold, then again it will be the open state. So these things will be like going on. So this is the like kind of things of the circuit breaker diagram of this one, like how it is change the status of these things. And if we say the circuit breaker of types of the circuit breaker, so two types of the circuit breaker is available. One is the like count based and another one is the time based. So a circuit breaker can be count based or time based, as I said. And a count based circuit breaker actually switch state from open close to open if the last n number of calls failed or were slow. A time based circuit breaker switches to an open state if the response in the last n second failed or were slow. In both circuit breaker you can also specify the threshold for failure or slow calls. So these are the two types is available, like one is a time based, another is a count based. So this is overall like architecture and diagram and the theory of this circuit breaker. Now let's check like how we are going to implement the same thing in our real project, right? So as I said, I already given one example like e-commerce kind of thing. Like one is there is one order microservice, another is the stock microservice, and then here we will implement this circuit breaker. So how it will look like in the real coding. Let's check out this code. So for demonstrating this circuit breaker, what do we need actually? So I have created two microservices. One is like order microservice, another one is a stock microservice. So order microservice from here what we will do, it will like from here we can place the order, and internally this particular microservice will talk with stock microservice. So as you can see over here, so from this controller there is an order. So from here we will place the order. It's having one like request body. If we open this one, it's having this item, quantity, amount, payment, order ID and address. So this DTO will be passed from the postman or anywhere else. Then like from here we will call this stock update stock API, and what it will do, it will actually deduct the quantity from the stock service. So that we are doing here. So that means here we are for calling this stock API we have used the REST template, as you can see over here, REST template dot post because this API is a post API. Okay, so that's why, because I also need to pass this request. So as you can see in the entity I bind this particular request. Okay, and from the response we'll get the order status. It will be like success or success or maybe some exceptions. So that's why I'm keeping this status. And now check out this stock ms. So here there is a update stock. What it will do, it will based on the item, it will search the data from here. If it is not exist, then it will throw exception from here, else it will just update the entity. Okay, and in the like as a response order status, we are setting this field as success, and from here we are returning this return this order status. As a database I have used the h2 in memory database, and so this is the thing. And one more point, okay, as initially the stock will be empty, so for adding the means like items into the database, so that's why we have I've added this one, add item. So from using this one we can add the item into the database. Okay, so this is the like brief idea about this ms. So let's now start this one. Let's try, like if we are like from the order controller, if we are try to call this stock controller, let's check about like how it will behave without circuit breaker. So let's say one situation, we are open this order ms. Let's start this one, run as Spring Boot app, but we are not opening this stock service. So that means stock service is not available. So in this scenario, what we will get, like we will get maybe internal server error or something, right? Let's start this one. It started, right? Let's call this let's try to hit this orders API. So for checking this one, what we did, I will like from order like postman we can try. Okay, this is the postman. So let's try to call this service. Okay, okay, it is trying. Okay, what we will get, we'll get internal server error, right? Now if we check from this console, so here we can get like connection refused. Okay, now here actually if we implement the circuit breaker, then from the circuit breaker what we will do, we will defining some fallback method, and this fallback method actually from the fallback method we can return any customization method. Means it will be like from this response user can easily understand like what is happening. Okay, or maybe we can also throw some dummy response over there, so that it will actually they are not able to aware of what is going on the internally. So let's implement the circuit breaker. So for implementing the circuit breaker, let's close this one. Okay, for implementing the circuit breaker, what we need to do, we need to we need to add some kind of dependencies which are related to the circuit breaker, right? So let's open the POM one, and here what we will do, we need to first add the actuator. So why we need this one actuator? Just to monitor like the health of the applications. Okay, so as in my the PPT or in my the presentation, what I said, like there is some state I was showing, right? One is the like open, closed, and like hub open. So just to check those status, means monitor those status of the circuit breaker. So for this we need to enable the health mechanism. So those kind of health checking is be enabled by the means maintained by the actuator. So that's why is actuator is needed. Okay, Spring Boot. Okay, okay, start actuator, and also the AOP is needed because with this, these are related. Okay, next what we need to do, we need to also add the like Resilience4j Spring Boot 3. As I am using here Spring Boot 3, so that's why it's a Spring Boot 3. For this, this is the like this dependency we need to add in our pom.xml file. So this dependency wise done. Let's save this one. Okay, so it will download all the things. Okay, now what we will do, we need to like use some annotations for enabling the circuit breaker, like @circuit breaker. Okay, here we need to provide the name of this service, like order ms. Next, we need to define some fallback fallback method. So here actually we need to define the fallback method, like if it is in case of any issues from this particular method, then it will goes to the fallback method, and from the fallback method it will throw us the response. So fallback method, something like fallback do order, and this method we need to create over here. It will be a public, and the return type also same, like order status, and this is the method name. Okay, here we need to do throwable. Okay, next here we need to define this one. Okay, so fallback is done. Now for again we need to like do some kind of configurations for this one. So for that we need to provide those configuration in the YML file. Okay, okay, okay. So first actually we need to provide the health related configurations for just to checking of the. Okay, so these are the actually health related like configuration: management health, circuit breaker enable true, endpoints health, show details always true. Okay, next we need to like provide Resilience4j related configuration. Circuit breaker dot instances. Here actually we need to pass the instance. Okay, so this is the order ms. Okay, order ms. Then we need to provide register health indicator true. Okay, next event consumer buffer size, for example star 10. Next, like failure rate threshold, for example 50%. Next, minimum number of calls, for example 3. Next, like automatic transient up to enable from open to hub, and hub to open, from open to hub open enable 3. Okay, automatic transitions from open to hub open enable 3. Next, wait duration, like in between how much second it will open, or wait, it will wait, right, to in open state. So for example let's say 3 second, or let's say 5 second for example. Okay, next, permit number of calls in hub open state. Okay, how means if it is a hub open state, then how many call we need to allow, like 3. Okay, next, sliding window size, for example 10. Sliding window type, it's a count based. Okay, okay, it's a not 3, it's a true. Okay, so this is the configurations of Resilience4j. So this configurations is done. Now what we will do, we will just like start this server like order ms. Okay, okay, instead of this keep this one, keep this one, stop this one, let's rerun it again. Okay, it's started now. Let's try to hit this one. Okay, one more point actually here. So as we can see, currently only we have been start this order ms, right? Means we are not starting the stock ms. So in this situation, if we try this one, let's try this one. So as you can see, we are getting called fallback method, and this particular response is coming from here, right? So that means if that is the we have not opened the stock service, so it is not actually able to not able to call this service successfully, right? So that's why it's returning this one. Okay. Next, if we check the health of this one, so for the health checking, we are having this service actuator.health. So you can see buffer calls this failed is 1. So now the state is closed, right? Okay. Now again, if we try this one 2 times, still it will be a, you can see like the failed calls is 2. Still the state is closed. Now again, if we call this one 3, now the state is open, right? So we have already like tried 3 times, and 3 times we are getting failed. So that's why the state is updated from close to open. Now if we again check the status, so it will be updated from the open to hub open. Why? Because here actually like in the configuration we have mentioned the permitted number of calls in Hapaman, that is fine, but with duration in open state 5 seconds, means it will be stay in the open state in the only 5 seconds. After 5 seconds it will be again like going to the from open state to the like hub open. So that's why the status is changed to from the open to hub open. So now let's start the stock ms. And the stock ms is open in 8082. Okay, so first what we need to do, we need to like add the stock. So for example books and the 100 items, let's add this one. It's success, right? Yes, we are getting the 200. Let's open the database console. I have opened here, connect. Okay, so this is added. Okay, next so this is done. Now try to add this order. It is success, remaining this. Now check the health. It is still hub open. Okay, try again. Is should be still hub open. Again try. Now it's 70. Now check the state. Yes, now it's up and the state is the closed. So why it is closed? Because like as we have mentioned in the configuration, like in the hub open, as you can see in this here, permitted number of calls in hub open state is 3. So like it will allow only the 3 calls in the hub open state. So after this 3, if it is means if all 3 are success, then from the hub open 2 it will go to the close, right? Because the now the call are getting success, so that's why it will be like closed, not open, right? Again, if we down this like, or maybe it will say it will take some more time, or maybe the again like stock image is down, then again it will actually from the like close to, it will go to the open state. So this is this way, like it will actually from here we can also check, or maybe we can monitor like how it will it is happening actually, the state change of the like circuit breaker, how it is managing. So this is the like thing. So this is like about this circuit breaker. In this way, like actually this circuit breaker is actually working, and how also it is maintaining the state in this way, like from closed to open, open to hub open, and then again hub open to open, or maybe hub open to closed. So this particular circle is going on, and also for maintaining the health of the means this particular circuit breaker means of the application, we can say. Using the actuator we can get using the actuator we can check the health of those things. So that's all for circuit breakers. In the next sessions of Resilience4j, I will definitely try to cover other modules too. If you guys having anything, please do let me know in the comment sections. Thanks for watching. See you in my next videos. Bye bye.